Hello and welcome to the 9-6 notes. In this section of notes, we're going to be talking about some quadratics. So a couple different forms of quadratic equations that we'll see. Standard form, where we have y is equal to ax squared plus bx plus c. This form is not super helpful when we're trying to graph. It makes it easy to find the y-intercept, but that's about it. But a lot of times we'll see quadratic equations in that form. Vertex form, definitely more helpful when we're graphing. That one looks like y is equal to a times x minus h all squared plus k. So we can easily find the vertex from that form and then graph from there. So, for example, in number 1 here, we have to find a few things: the vertex, axis of symmetry, x and y intercepts, and then sketch the graph. So first thing I'm going to do is sketch this graph. So this form is actually, you could call it standard form, but you could call it vertex form too, because there's no b, in this case b is 0, so we don't see that x there. So if I wanted to find the vertex, I just need to figure out what makes this 0. What can I put into x? So in this case it would be 0. And then if I do put 0 into x, I get -7 for y. So there's our vertex. The a value is 1 in this case. So there's a couple different ways that you could use this pattern, but I use the odd numbers. So like 1, 3, 5, 7, and so on. And that's how I get from the vertex to all the other points on the graph. So I treat these as slopes. Whatever the a value is, though, I have to multiply these numbers by that a value. Since the a value is 1, these numbers are just going to stay the same. So if our slope was 1, to get to the next point, I would go up 1, right 1. I don't know why I made a heart there. There we go. And then we always do the same thing to the left, because these graphs are always symmetrical around the vertex. So we use that one. Next, I would act like I have a slope of 3. So I go up 3, 1, 2, 3, right 1. Same thing on the left. Then up 5. 1, 2, 3, 4, 5, right 1. And here's our graph. Now again, you might use a slightly different pattern, which is fine, whichever way makes it easier for you. But I like to just use the odd numbers. So for the vertex, we found that was at 0, -7. The x-intercepts are in between 2 and 3. So if I wanted to find the x-intercepts, I could set y equal to 0. So I can say 0 is equal to x squared minus 7. So add 7 to both sides. Take the square root of both sides. I'm just going to move the x on the other side. So I'll get plus or minus square root of 7. Square root of 7 would be between 2 and 3. Because square root of 4 is 2 and square root of 9 is 3. So that it makes sense. So I'd have square root of 7 comma 0. And then negative root 7 comma 0. Axis of symmetry is always where the vertex is. It's always a vertical line. So our equation will always be x equals whatever the x value of the vertex is, in this case 0. And the y-intercept, in this case, happens to be the vertex, 0, -7. In the next example, this is in vertex form, so I can easily find the vertex. So inside of the parentheses, what x value will make it so I have 0 squared? If I plug in 6 for 0, sorry, 6 for x, then I'll get 0 squared. 0 squared is 0. 3 times 0 is 0. 0 minus 3 is -3. So our y value would be -3. So our vertex will be at 6, -3. So again, I'm going to use the odd numbers to find more points. But I have to multiply these by the a value, which is 3. So 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. 21, and so on. So what this means is to get to the next point, I would basically have a slope of 3, which means I go up 3, right 1, same thing on the left. To get to the next point, from my new point, I would go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right 1, same thing on the left. So if I graph this parabola, it would be kind of steep and looks something like this. Our x-intercepts, we can clearly see, are at 5, 0 and 7, 0. Our axis of symmetry, always x equals whatever the x value of the vertex is, so 6. And then for the y-intercept, I can plug in 0 for x, so I get y is equal to 3 times 0 minus 6 squared minus 3. 0 minus 6 is negative 6. Negative 6 squared is positive 36. 3 times 36 would be 108. And 108 minus 3 is 105. So our y-intercept would be 0, 105. So obviously, it's not going to fit on our graph. This graph is pretty steep, so it would take a while for it to get to the y-axis. Moving on to example number 3. So this time it's in standard form. So it makes it a little tougher to find the vertex and stuff like that. But I can easily find the y-intercept from this form, because if I put 0 into x, these both go away and I'm left with just plus 1. So 0 plus 1 is 1. So our y-intercept is 0, 1. So I know I'll have a point right here. When it's in standard form, we have a couple options. One option I see with this one is I can factor this. So if I factor this, I'm going to get f of x is equal to x plus 1 times x plus 1, which could also be written as x plus 1 all squared. So now this is actually vertex form. We have something squared. We just have a plus 0 at the end here. So what number could I plug into x to get 0 squared? That would be negative 1. If I put negative 1 in there, I end up with 0 for y. So our vertex is at negative 1, 0. So our a value is 1. So if I have the vertex, I could go up 1, right 1 to get to the next point. Same thing on the left. And I could go up 3, 1, 2, 3. So I'm just using that odd number pattern. The next I would go up 5, 1, 2, 3, 4, 5. Same thing on the left. So here's our parabola. So our vertex is at negative 1, 0. Axis of symmetry, x is equal to negative 1. X-intercepts, we only have 1. And it's at negative 1, 0. So sometimes when it's standard form, one of the options we have is to factor and graph from there. Now it won't always be something squared when we factor, but these would both be x-intercepts, so we could go from there. In the next graph, we again have standard form. This one, however, is not factorable. So there's a couple different ways we could go about doing this. If I wanted to find the axis of symmetry right away, that would give me the x value of the vertex. And once I have the vertex, it's going to be easy to graph. So to find the axis of symmetry in standard form, I say that x is equal to negative b over 2a. So b is the value in front of x, the coefficient of x. So we get negative 4, all over 2 times the a value, which is negative 1. Negative 4 is positive 4 over negative 2. So I get x is equal to negative 2. So I know our axis of symmetry, x is equal to -2. That's what we just found. So this is the x value of the vertex. To get the y value, I can plug in -2 into the equation. So I'll have -2 squared minus 4 times -2 plus 1. So I'll get -4 plus 8 plus 1. So -4 plus 8 plus 1, that would be 5. So our vertex is going to be at -2, 5. 1, 2, 3, 4, 5. Y-intercept is easy to see from standard form here. If I plug in 0 for x, I'm just left with 1. So I know I'll have a point there. But if this is the vertex, the a value is -1. So my odd numbers, 1, 3, 5, and so on, are just going to be multiplied by -1, so they become negatives. So that just means I go down instead of going up. So I could go down 1, right 1. Same thing on the left. Down 3, right 1. There's a point there, good. Down 3, left 1. Down 5, right 1. Same thing on the left. So here is our parabola. Notice it's upside down because our a value is negative. Our x-intercepts are not whole numbers, so we'll have to figure out what those are. There's a couple different ways we could do that. Completing the square or quadratic formula. I'm just going to use the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. -4 is +4 plus or minus 16. -4 times -1 is +4 times 1. Just be +4. 2 times -1, -2. So 4 plus or minus square root of 20 over -2. I can reduce the square root of 20. So that's 4 times 5, so 4 would come out. The square root of 4 is 2. We have 5 left inside. Now I can reduce these 3. So I get 2 plus or minus root 5 all over -1. I'm just going to put that negative in front of the 2 there. So those are our x-intercepts. So I'm just going to put -2 plus or minus root 5. If you want to write it in coordinate form like I was, that's totally fine, but I'm just going to leave it like that. Last thing I want to mention is completing the square. This is something we will be doing in the future, a little bit more of. This should say y equals. So if I'm completing the square here, I need a specific number to be here where c is. I do not want 1 there, so I'm going to get rid of that. So y minus 1 is equal to x squared plus 6x plus something. To figure out what that something is, I take the b value, divide it by 2, and square it. So 3 squared is 9. So I need to add 9 to this spot. So I'm going to do it to the other side as well. So y plus 8 is equal to x squared plus 6x plus 9. The reason I needed 9 there is because now this is a perfect square. So it's going to factor into x plus 3 squared. So this number will always be half of b and the square root of c, which it is. Then just subtract 8 on both sides and we'll have vertex form. So there we go. Another example of this would be in number 6. So I don't want that 1 there, so I'm going to subtract that. So I have y is equal to y minus 1 is equal to -x squared minus 4x. But I also don't want a negative x squared. I need a positive x squared. So what I'm going to do is I'm going to factor out a -1. So now inside the parentheses, I'll have which is positive x squared, plus 4x, and then I'll have plus something to complete the square. To figure out what I need to add there, I take the b value, divide by 2, and square it. So that would be 4. So I need to add 4 in here. However, if I add 4 inside the parentheses, keep in mind we're distributing this negative, or we're multiplying everything in here by a negative 1. So I'm not actually adding 4 to the right side. I'm adding 4 times negative 1. So I'm adding negative 4. Or subtracting 4. So I'd have to subtract 4 over here. So I have y minus 5 is equal to negative x squared plus 4x plus 4, which is going to factor into x plus 2 squared. So then just add that 5, and we'll have y is equal to negative quantity x plus 2 all squared plus 5. So now we have vertex form, so easy to graph. And that's going to be it for the notes.